Okay, Mr. Baumer here. Thanks for tuning in today. We are continuing in Unit 6, which is solving systems. And right now you can be listening to me and you should be writing this down, the objective, on the bottom of the note sheets that you took home with you, all right, as your homework to complete. Our objective is student will be able to solve systems of equations using elimination. All right, so again, let's refresh our memories while you're writing that down. Just be listening too about the methods we have learned to solve systems. The first one we learned was graphing. Now, what we were doing there is we were graphing each line and looking to see where those lines intersected. Wherever they intersected, that's the solution to the system. So the solution is an ordered pair that has to make both equations true. All right. Then after that, we did a day or two on solving systems using a process called substitution. And now we're going to be learning a third method, which is called elimination. So hopefully by this point you have the objective down. If not, you can hit pause, but we're moving on here. So on your note sheet, first of all, some notes to fill in. Over here in the background section, systems can be solved in three ways: graphing, substitution, and elimination, which we're going to be learning today. Now, let's give you a little introduction to this elimination method. Your goal is to add the equations together to eliminate one of the variables, thereby creating an equation with only one variable, which can then be solved. So, got some steps here for you, and keep coming back to these when you try and do these on your own. Line up your equations so that the x's, y's, and constants line up. Try and squeeze that in there. All right, so that your x's are on top of your x's, your y's are on top of your y's, and your constants are on top of your constants. All right. Now, if you add them together, will you eliminate a variable? Meaning right away after you've lined them all up, can you add them together and eliminate a variable? If you can, you're in good shape. If not, we're going to need to do a little work to get there. That's why step 3 says, if not, what would you like the term here is coefficients. What would you like the coefficients to be so that you would eliminate a variable? Now, things that eliminate each other are things that are opposites. So one variable has a coefficient of 3, I'd like its partner in the other equation to have a coefficient of -3. All right, but we're just thinking about what do I really wish those would be. Step 4, multiply one or both of the equations by a number to create opposite coefficients on one of the variables. Then we're going to add the equations together to eliminate a variable and create an equation with only one variable. If you remember, just like in substitution, that was important that at some point we create an equation that only has x's or only has y's. That way we can solve, right here, step 6, for that variable. Now, step 7, take that value back to one of the original equations and substitute it for the variable and solve for the remaining variable. So again, we're just writing in these words to make sure you're actually watching the video, taking the notes, but I will be referring back to these steps as we go through this first problem. So, step 1 again says line up your equations so that the x's, y's, and constants line up. And you'll see here that the x's line up and the y's line up and the constants line up. So I think we have achieved step 1. Now the question is, if we add these equations together, will we actually end up eliminating a variable? And you'll notice here that the coefficients of y's are -2 and +2, which are actually opposites of each other. So if we add these equations together, we will actually eliminate a variable, which is what we want. So right away we can add the equations together. 6x equals -19 plus 1 is -18. And now, again, we're down here now to step 5. All right, we added the equations together to get an equation with only one variable. Now we need to solve for that variable. So I need to divide both sides by 6. So I have now found that x equals -3. Now, it says take that value back to one of the original equations. So, which one would be easiest to work with? Well, this one has a negative, which some people might want to avoid, all right? This one has pretty small numbers. It doesn't have a big number like -19, so some people may choose to go to equation 2. And if we go to equation 2, what we're talking about is saying that 5x plus 2y equals 1. And now we're going to substitute. 5 times something plus 2 times something equals 1. Now, where can I substitute? Well, I can actually substitute in here. X is the same thing as -3. Y stays y. Now, we have a variable with only one, or an equation with only one variable, so that can be solved again. So this is -15 plus 2y equals 1. Adding 15 to both sides, 2y equals 16, so y equals 8. So the solution, it turns out, to this system is x is -3 and y is equal to 8. Now we could check our work by making sure that that makes both equations true, and you can do that. But let's move on to the second one. Again, step 1, line up your equations so that the x's, y's, and constants line up. Well, have we done that? Yeah, we got x's lined up, we got y's lined up, and we got constants lined up. So I think we're pretty good there. Step 2, if you add them together, will you eliminate a variable? Let me see, that'd be 7x. That would be 2y. Nope, I don't eliminate a variable. So I got to come back and say to myself, I got to actually do some of these other work. What would you really like them to be? Well, if I focus on what would be the opposite of 3, I really wish that number right there were a -3. So how do I make it a -3? Well, I'm going to multiply this entire equation by, +3, because I want to make it a -3. So this first equation is going to stay exactly the same as it is. But the second equation is going to become 15x, because that's 3 times 5x, minus 3y equals 39. Now, when I add the equations together, I actually end up eliminating a variable. I get 17x, the y's cancel each other out, and I get 51. If I divide both sides of that by 17, I wind up finding out that x is equal to 3. Now, I haven't solved the system yet. Remember, we have to find the y value now, but where can I go? I can go to either one of the originals or one I made. I could go to this one, but I would choose one of the originals. In this case, I would choose this one. There's no negatives. Let's do it. 2 times x is now 3 plus 3y equals 12. So 6 plus 3y. Let me fix that 6 there. Equals 12. So 3y equals 6. I subtracted 6 from both sides. So y is equal to 2. So the solution to this system is x equals 3 and y equals 2. And again, that would make both of the original equations true. Now, let's look at the next problem. In this one, solve the system using the elimination method. Again, let's see if I got my x's lined up. Yeah, I got my x's lined up, I got my y's lined up, I got my constants lined up. Good. Now, if I add them together, would I eliminate a variable? No, I wouldn't get rid of the x's. I wouldn't get rid of the y's. So I'm going to have to multiply one or both of the equations by something. Now, could I turn a 2 into the opposite of this one? Yeah, I could turn a 2 into a 3, but it's not that easy to do. And here it's not that easy to do. So in this case, I may choose to, instead of like on the last problem, we multiplied one equation by something, I may want to multiply both equations by something. Now, in terms of the x's, that could easily be 6 and -6. And the y's, that could easily be 20 and -20. So I'm going to go for the smaller one. I'm going to go for this. So I'm going to try and turn these into 6 and -6. So what do I have to do? Well, let's multiply the entire first equation by 3. So that's going to give me 6x plus 15y equals 78. Had to think about that one there for a second. Now, this one, I'm going to multiply this entire equation by 2. Because remember, I want the coefficient here to be the opposite of 6. So now it's negative 6. Minus 8y equals 2 times negative 25 is negative 50. Now I'm ready to add them together. And guess what? I eliminate the x's. Perfect. I wanted to eliminate a variable. Now I have 7y equals 28. And hopefully some of you can see that that's going to work out nicely for us, because when we divide both sides by 7, you get y equals 4. Now, we're not done solving the system. We found y. Now we can come back to either one of the originals or one of the ones we made. I'm going to choose this one. There's no negatives. I'm going to choose that one. 2x plus 5, and now I can replace y with 4 equals 26. And now I'm just going to solve that one. Well, I get 2x plus 20 equals 26. I get 2x equals 6. So I get x equals 3. So again, the solution to this system is x equals 3 and y equals 4, which of course would make both equations true. Now, we got one more thing to do here, but I'm going to give you a little break, and we're not going to do that one. We'll start next class with that one, which is how to solve a system in all 3 ways, just so that it's driving home the fact that we are going to be able to solve systems in multiple ways, but we need to understand how to do them all, and then we'll work on how to choose which one to use. So, actually, you should do this right now. Since you have this note sheet at home with you, come in with this complete. I want you to solve this one by graphing, and then I want you to solve it by using substitution, which of course, this one sets itself up pretty easy for substitution, because in this equation, y is already alone. And then I want you to come back and I want you to choose to solve it using elimination. Now in that case, you're going to have to rearrange one of your equations, all right? If it were me, I would move this 2x to the other side. So I would make this first equation 2x plus y equals 3, and the next equation would stay the same. That way, now you have accomplished step 1, which is you got your x's lined up, your y's lined up, and your constants lined up. So when you come in for next class, I expect you to have all these notes done and this problem solved in 3 ways. Now, of course, if you're getting different answers in the different ways, you got to look at that. All right, so we will see you at the next class. Thank you. See you later.